I would like to call on stage Mayank Mahavar. Are you ready? And he will be teaching us framework design lessons. So he is going to talk about his experience of building Catalyst Core for 260 million users. So give a warm and a big round of applause for Mayank.
Hi guys, this is Mayank and I work with Tata and MG. Today I'm gonna talk about the lessons which we learned while building a framework which allowed us to ship product features and web experiences to millions of the user, get the feedback from them and built on it. So till now, what we did is this framework is open source. So every time we faced any challenges, any problem statement came to us, we created a discussion of it, and we started logging it on the GitHub. So I'm just gonna crush it all and create a presentation out of it. And if you guys want to deep dive it, understand the metrics more, you can scan the QR code and follow the discussion page, right? So moving on. Before I start my talk, I want to talk about the heritage which we have got. So last year, Saurabh came on React India and open sourced our internal tool. And I'll just give you a gist of it, what he talked about. It's just that what are good APIs and what are bad APIs, and how every layer of application matter when you are trying to build a web experience. You guys can check the video or you can scan the QR code and check about it. So I have summarized my talk in 3 key sections. The first part is the problem statement. The second part is the solutioning bit. And the third part is, did it make sense, right? So defining the problem statement is very important because as an engineer, sometimes what I do is I find something cool and I start experimenting it without thinking that whether it will benefit our devs, our product, or it will help in improving something. Sometimes that inner engineer of me just want to break things and just start building something. So until or unless I define my problem statement, I can't understand whether I'm gonna create an impact or not. Then comes the second part of it, which is the solutioning bit. Was I able to solve it or not? If I able to solve it, then awesome. So we did solve it, and then came the important part is the impact, right? How was the impact? Did we went in the right direction? Did we find something else, or we made it worse or better? So we made it better. We'll show you. So I'll give you a scenario which you guys can refer to. For example, assume there is a one guy, one developer who knows web, who knows Android, and who knows iOS. Now the product comes to the developer and says, I want to ship a feature and I want to share it with the shareholder, and I want to see the feedback from them and mature the product, right? So what happens is the developer initially make the feature in the web, share it with the shareholders, mature it, and take it to the production. Then he developed in Android and iOS as well. But what happens is, even if I had the problem statement on the first day and I solved it on the second week, I had to replicate in the 3 different platforms, and sometimes other platform takes more time. Assuming the web took 2 weeks, let's say Android took 3 weeks, and iOS took the similar amount. I had now 8 weeks of development, which I had to do. And I have now 3 code bases. And assuming even in a perfect world, I obviously forgot a corner case or a scenario where the bug increased. So now I have to solve the same bug in 3 different platforms, and the same iteration happens over and over again, right? So let's break it down, the problem statement again, into 3 crisp points, okay? This first part is, the same developer can't do it. So you have to have a different teams, Android, iOS, and the web team. So you have a high cost of maintaining all of those teams. You have to make sure that they communicate well, everybody are on the same wavelength, and so and so. And then comes the second part, inconsistency. Even if how good everyone as a developer, how good everybody communicate to each other, the experience will always be different. I'll give you an example. So we were building a ad patient page which had like 10 to 11 fields, and everybody was building in the separate platform. And so what happened is that sometime that patient fields will be pre-filled by default. So let's say this 5 fields are already filled. The user has to scroll to search which is the next field. They have to enter the value. So what I did, I just implemented scroll to view. So if whatever fields are already filled, I'll just skip them and focus on the field which requires the attention from the user. So it became better for the user. But when the same experience got built in Android and iOS, this was not part of the requirement, so it got skipped. So there will always be inconsistency when different developers try to build it, because everybody likes to build their solution differently, right? And then comes the part of the slow velocity. Since there are different platforms which you are trying to build and then take it to production, and you have a different release cycle to it. So even if you had solved a problem in a particular platform, it is taking more time to take it to another platforms, right? So what is the solution part of it? We thought we will create something called web-based multi-platform framework. Not sure why is it not updating here. Okay. So we created something called web-based multi-platform framework, because at the core of all, we believe that every web dev here doesn't build websites. You guys build web experiences, right? That does not know any bound. So whenever you are building anything, you don't think that it will not go to Android, it will not go to iOS, or it will not work here. The moment you are building, you are thinking it will go to all possible devices, and you are trying to solve a problem which will help the user to meet their needs, and you are creating that beautiful experience. And that beautiful experience has to elevate to all platform without you doing the repetitive work. The tool needs to become better rather than the dev has to do the repetition of a work, right? Being said that, what I'm trying to say is I will build it once and I'll make sure that it will run anywhere, right? And to do that, what will I gain from it, right? So initially, I was taking 8 weeks in that scenario. Now I have 2 weeks. In the 2 weeks, I have my web app, at the same time my universal app that gives me single code base. At the same time, if I had a bug, which I should be having it, so I will have only one bug. And if I solve it in web, it will be solved in all 3 platforms. I have a 3x cost reduction. My delivery becomes faster. I am able to give a consistent quality. Whether it is a good quality or bad quality, that I don't know, but it will be a consistent quality, right? And this is not something which we thought about in a closed group. This is something which we have tried and tested on our 1MG platform, where we have understand from the users what are their feedbacks and how this whole thing works. And at the core of the vision which we have, we believe that web dev is the future, and the future is here. If we have, just imagine, let's say a new API comes today. By tomorrow, there will be 1,000 examples built on top of it, and you will be saying, this is so awesome. So why do we limit it? Why do we limit it only to web? Let's build it, let's take it to another platforms as well, right? So now comes the question, how are we gonna do it? Did we solve it? Yes, we did solve it. We use something called web views, which allows you to run browsers in your app. So your native app will be running a browser inside it. So the moment you deploy your web app, your native app updates. So the more focus which you have to follow on is to build a beautiful web experience, and that will elevate to your native apps, right? But as we all know, if I gain something, I lose something, right? So if I am able to run a dynamic app without updating on App Store and Play Store, there should be some shortcomings to it. There should be some scenario where there should be some scenarios where there will be limits to it, right? We started understanding those limits, and with that mindset, we thought, let's just break all the limits and figure out most of the challenges and see if we can do it better, right? There are multiple challenges which came to us, but at the end, I'm just gonna explain few of them to you, right? For every these topics which I'm gonna explain, there is a separate GitHub discussions for them, which there will be QR code at the bottom of it. You can scan it and check the matrices side by side with you, because I can't explain everything right now. So being said that, let's start with the first tools of the trade, which says web view pooling and threads, right? So I explained, right, I can run a browser inside an app, but how does that work? So by default, when you navigate to any web app, you are either clicking a link or you have pasted the URL in address bar and started, you pressed enter and your page starts streaming to you, right? But how does it work in WebView? So initially your app will start. Once your app launch finishes, then WebView instance or objects get created and then the navigation starts. So this amount of time is very considerable and it feels like your app is slow. This is something which we can't have. We can't let user feel that our app is slow. So what did we come up with? We come up with something called web view pooling. What is web view pooling is, we pre-warmed different web views to make sure that as soon as your app gets and your page starts streaming to you as soon as your app starts as soon as your app has launched, right? Now there is something when we try to understand the web views and this universal app part bit of it, right? We understood that there are something which native does it better rather than the web layer, and there's something which web does it better. And we don't want a web dev to leave the web ecosystem and then go do something in native, right? So there is something better which is called threading, right? Traditional approach is one web view, one thread, and it's a sequential loading. So it feels slow. How do we solve it? We started creating multiple threads and allowed parallel loading. That happens without even leaving your web ecosystem. We understood that we have to do a heavy lifting when it comes to image processing, complex calculations, and file operation. But at the end, when you're trying to build that experience of it, that is controlled by your web layer, UI, UX, business logic, and user interaction, right? So how does this whole threading architecture works? So whenever any request get formed, we first try to understand whether the device can create the threads, whether the threads are available or not, right? So first we check whether the threads are available or not. If the threads are available, we check what kind of operation it is. If it is a main UI thread, we don't touch it because that's how it is supposed to work. But let's say it's a non-blocking UI thread. It's a 10 async call of yours, as a 10 async calls on the network, getting some assets of it. We take that calls, we create multiple threads in background, and we attach all of those requests to it. Once the response comes back to it, we update the main UI thread with it. So that way, without even leaving your web ecosystem, you get the benefit of using these threads, right? And what happens when you have an I/O operations, such as using a camera, image processing, attaching a file, opening a file, all that happens by native, and that happens in the background, because of which your web remains smooth and it feels really nice. So again, so if you guys want to see what were our initial approaches to this, what did we think of it, whether we wanted to do it or not, so you can check the discussion link and see what matrices we come up with, what were the impacts of it, and that's it. Let's move to the next part of it, which says universal caching, right? Now, most of you who would have either built your own web apps or anything, you would have come across the caching bit of it. And you will be asking me, I know caching, I can figure out my caching layer, okay? You don't need to do that for me. But even if a web is not slow, even if the web app is not slow, it feels slower than the native app. And there is a reason for it. Because web has something which native doesn't. So web has a network dependency which native doesn't. Native serves their asset directly from local. So that dependency can never be removed. So how do we solve it? We started caching the network calls in the local so that whenever it is required, it comes from the native. That way it feel like a native layer. So how does that whole scenario works? So assume any request start coming to you, any resource request comes to you. First of all, we check whether that resource, whether that request should be cacheable or not, based on the cache pattern which is provided by you. So once we understand that it is not cacheable, we let it go through the main network call. But if it is supposed to be cache, first we check whether it is available in the cache or not. If it is not available in the cache, we mark it as a cache miss, then we get it from the network, then provide it to the web view, and in the background, we start storing it. So next time when you come, it should be available. So next time when you come, we check what is the freshness of that request. If it is fresh, there's a limit to it, which you guys can configure. If it is fresh, we gave the cache back to the web view. And if it is stale, means there's a time where it was fresh and it is about to expire. In that amount of time, what we do, we provide the cache back to you, but in background, we revalidate the request and update the cache. And let's say worst case scenario, it is expired. Then what do? We discard the cache, get it from the network, and then send it back to you, right? This is something which we are doing to cache your whole assets, right? But there's another part of it, which is how are we managing that cache? So this is something we try to solve it by creating a two-tier architecture where we have a memory cache separately and a disk cache. So every app have their own memory. So whatever is present in the memory get retrieval very fast, and there's something we create a disk. It's like a folder where we just cache everything and we load it to the memory, and then memory takes over, right? And at the same time, we try to figure out few algorithms, and we ended up building a priority queue. And so that allowed us to make sure that whichever is the most recently used stays on the top of your cache. So whenever it's somebody try to retrieve it, it comes way faster for you, right? Again, you guys can check out the whole discussion if you guys want to. With being said that, I move on to the next bit of it, which says native bridge and the base hook, right? Till now, you guys have understood that I was able to open the web inside my native platform, and I'm able to make it feel like a native as well, right? But there is some part which is still missing out, which is like interaction to the native APIs, like interacting with the camera, files, and so and so. Even though web has that experience, native has cracked it better. And we want to reuse that part without leaving the web ecosystem. So how do we do it? Even if we think of it, like if let's say today I want to build it, there is all platform try to interact with the same API in a very different manner. Web will have a different API, iOS has a different API, Android has a different API, right? So now we had two problems. First, we want to access it without leaving from the ecosystem. Second part is, I don't want to write different code just to do the same part of it, right? How did we do it is, we use custom hooks as well as at the same time we use the JSI layer. So what is the JSI layer is, it's a bridge which let you communicate between native and web, right? So what happens is, as soon as you have a custom hook for anything and you invoke any function, it first registers that API to the JSI and sees whether that API is available or not. Once it is available, it invokes that particular function to the native, and native takes care of that particular request and gives the data back to you. Then JSI updates that particular hook and then updates the states. What it does, it gives you the ability to play with the states however you guys want to be, right? And how do I even use it, right? So you use a single line of code. You just use import the API which you want to use from the Catalyst core hook, and then you're good to go. The platform awareness comes from us. We figure out which platform it is going to be, and based on that, we figure out which API has to be called. There's a zero native code. You are not gonna write any native code. Native code will be figured out in the background, and all you have to do is make sure that you build beautiful web experience. That's it. That's all you need to do. So now you guys must be thinking that, yeah, I have figured out most of it, right? I'm running a web browser. I'm running a web browser inside the native part of it, and I'm able to cache the whole thing, and even if and now I have figured out the native API as well, right? So now the part is what is left. I've done it all, right? I made WebView on steroids. I figured out, make sure that the perceived performance is better. I made sure that I'm able to get that native API ka UX as well. Now, what is left? What left is one day we were one of our team which was using this framework came up to us and said that we are trying to attach a file which is 14 or 15 MB in average size, and our largest size is 20 MB. And because of that, the web feels very slow. So we understood one part immediately, that in native, it is very common to handle a very large files. You would have played any games, you would come to know that there's a 1.5 GB file got downloaded and it works like there's nothing there. So how are we gonna do this, right? Because this is something which will come up in a native app, right? So we thought of it to create a tri-file transport layer, which allows us to handle the native part of it, which allows us to handle these files on the native layer, and then allows us to take the advantage on the web part of it, right? So when the file is selected, we first try to figure out what is the file size of it. When the file size is less than 2 MB, what we do is we create a base64 data URI of it, and that is available with the object, which you can use it to show any image or any file of it. But if it is above than 2 MB, what we do is we spin up a server inside a native and then gives a dynamic route for that particular file. What that allows you to use it anywhere in your SRC, and if you want to create a request with it, you can just directly create a file object with it. And that way you don't have to, web doesn't needs to feel a slow, junky. It becomes way smoother, and things becomes better. 1 minute. Yeah. Again, if you guys want to see how the whole transport layer is and what were the things we initially thought of it, you can check the discussion page, and that's it, right? Being said that, we have figured out all, right? But if you guys would have known that with great power comes great responsibility, this is where we need to think on the next part of it, right? Since web is dynamic, that allows you to potentially access any URL, right? That means there's a security part as well of it, right? There's a security challenge. Malicious domains can be used, data leaks can happen, security vulnerabilities are there. So how do you deal with it? You whitelist. You will be giving us a whitelist, and we will use it to enforce it in the framework. That way, the developer is driving what is the security parameter of it, right? So what happens is, what this security parameter does, whenever we get that whitelisting part of it, that parameter is enforced on multiple levels. First thing is framework derives by it. Whatever you have said, this is what framework will do. Second thing, that validation happens on the build time. We do the validation on the runtime as well. This whitelisting part happens on build part as well, and we log everything of it, right? This gives you the architectural responsibility to make sure that what is your security parameter and how you want to make sure your app feels it, right? Now, being said that, there are, I think, initially I said, right, problem statement, solution, and there is an impact of it. Explain the problem, understood the solution, but did it make sense? So it kind of made. So we started talking to the devs, the shareholders, and the product, and we tried to understand what metrics were they. Did it made an impact, right? So with being said that, there was a metric called specific platform bug rate. So since this is a multi-platform, if there was no bugs such as that it works only in web, It does not work in Android. It does not work in iOS. If it works in one platform, it works in all the platform, right? Because of that, we got a confidence that it will work in all of it, and our specific platform bug rate was below 1%. Then comes the part of the engineering bandwidth. The engineering bandwidth decreased by 67%, and it is not only for the coding part of it. As a developer, all of you would have known, as soon as it stops working, you will be like, whom should I ask? Whom should I ask? So when it stops working in either Android or iOS, web guy is not going to the native team and asking, it's not working, can you help me out? He understands there's basically a web tag, which I can figure it out and I can solve it. That way, our engineering bandwidth decreased by 67%. And then comes a very interesting metric which we understood after talking to product, right? What happened is, if whenever we used to have a feature and we try to solve for it, we generally had to come up with which needs to go in all the platform. We had to have a meetings where we decide whether that can be solved whether that is a common solution or not. Because what happens is, which is simple in web, it's not simple in Android, and it's not simple in iOS. I'll give you a very short example. So for example, you use your web, right, in a portrait mode. If you just tilt it and made it in the landscape, it auto scale. It's a responsive. And that is normal for us. Yeah, it works, right? But in native, they have to maintain that state. The moment that state changes, they have to make sure that that works. So even if it is a simple in a particular platform, doesn't mean it will be simple in another platform. So we used to have discussion to make sure that one platform doesn't have a complex solution. Because of introducing this framework, what happened is that those meetings went away and we started focusing on the product part of it, right? Because we understand if it works in web, it will work in other platforms, right? Then other part of it is which we wanted to understand, did it add any overhead of it? What happened to the code review time? What happened to the, how much time it is take to ship it, right? So there was 0% code review time because previously we were building a good web apps, now also a good web apps. There were few more matrices which we understood that rapid deployment started happening. If we get a feature by Monday, we finish it and deploy it by Friday. That happens in all three platforms. And when it comes to the update part of it, product started experimenting more. They started to release more feature and roll back more features. So agile updates started happening in every 2 days because everybody was like, yeah, this framework works. It works in web. This should work it, right? That confidence started coming in the product and the shareholders as well. And then comes the part where we were able to update the previous versions app as well. So you will have apps which will have an older version app and a new version app. You can't update the older version app and in a different platform. But since this is a web, you can put a checks. For this version, I want to show the experience like this, and for this version, I want to show the experience like this. So you can update the app for the different versions simultaneously, right? Then we started asking for something called web view-based enhancements, like how much time we talked to the teams which were which were using this framework versus the team which were not using this framework. So the team which were using it, they were able to do the enhancement within 1 to 2 weeks, whereas the team who were not having their own team for each platform, they were able to do the enhancement in 1 to 1.5 months. That's what we came to know. Then comes part about the adoption bit. So the adoption was very smooth because there was nothing required to learn. Right? There are a few more matrices about what is the time to market. The time to market went improved by 85%. 8 weeks becomes 1.2 weeks. Now 2-3 tests per quarter in A/B testing becomes 15 plus tests per quarter. Quality and consistency drastically improve because there's a one code base we need to maintain. We could maintain it better, right? Being said that, right? So with this, I want to say that till now the limit was the tool. What we were building it, we would never thought it will not go to a certain platforms and so and so. And tool was stopping us to break free. So we went ahead and fixed the tool. You use it, and a single line of code allows you to build powerful native functionalities. to make sure that you bring that beautiful experiences to all the platform, right? Now, what is in it for you guys, right? What should you do, right? So what you guys should do is, you guys should go ahead, create a CCA app, create Catalyst app, rip CRA, but create a code base with it, and then follow the quick start guide, set up your system, and then create the first universal feature, and at the end, become an application engineers, right? Because I believe we are not web devs, we can be an application engineers because we can just create beautiful application as much as we want to be. And at the end, make sure that those users which are demanding more from you, they feel like, yeah, they got whatever they want, right? With that, this is my team, which we have been working on to build this framework. And we butt heads and make sure that whatever we are building should be according to the users. The DevX should be better, and it should improvise in some sense of manner, right? A very special thank to the whole 1MG core team, which tried us to play with this framework, gave us their input feedbacks, and at the same time, those users which asked us more and more. And I can go on about how they asked us, right? There was a keyboard fix and so, but I need to hurry on, right? With that, that's been my time, guys. This is the QR code for if you guys want to connect with me on LinkedIn. And there's an aggregated link where we have previous talks which you can go through. There's a slides, there's a documentation, there's a discussion group happening, and there's a Discord channel as well. So you guys can connect on with us. That's been my time. I'm here for remaining 2 days. If you guys see me and you just want to talk about it, not with this framework, anything you wants to come up, and if you want to try something on, I'm there, right? And hopefully I get to connect most of with you, and that's it. Thank you, guys.
React India.